Saxon Algebra 1/2, lesson 61. We are going to solve some equations that have two steps today. This is, to me, the heart of what algebra is all about. So you guys have definitely hit the big times here. There are three examples. Let's start with the first one. It looks like this. All right, we notice that it's an equation. We notice that it's got a letter in it, and we know that our job is to get the letter on one side of the equation. It doesn't matter which. We want the letter on one side, and we want to shove all the numbers to the other side. We think of them as fish, right? We want to separate all of the numbers and send them to the other side, just like you would swim schools of fish to one side of the ocean or the coral reef. Imagine a little Nemo, if you would. So we look at this side and we say, okay, we've got two numbers that we need to get rid of, right? We need to get rid of this 2 and we need to get rid of the 3. Now, I don't think I've told you guys this story before, but let me give you the metaphor of the day. Have you ever been in one of those friendship groups where there's 3 kids that hang out together? Imagine that you are the X, okay? You're the letter X, that's you. And there's 3 friends, but as often happens in groups of 3 friendships, 2 of the kids are a little bit closer and the third one is a little bit out in the cold. Still a friend, but it's never quite the same. I have been in those friendship groups and I have been one of the especially closest. And I've also been in the, you're really not the closest. You're the outsider. And that is cold, isn't it? But we're going to imagine that these numbers have the 3 and the X and the 2 are the friends like this. So what's happening is everybody's over at your house, your X, and it's dinner time. And your mom says, time for the friends to go home. And you drag your mom in the kitchen and whisper and say, okay, Mom, 2 will go home, but can 3 stay over for dinner? And your mom, who has a soft heart, says yes. So that's what happens first is this friend that is the third friend, they go home first. So we send them home by subtracting them because that's the opposite of adding, right? We do the opposite of whatever's happening here to send them home. Okay, bye. And now we have 3x equals 7 minus 2 is 5. Okay, cool. So 3 stays for dinner and you guys hang out and, play dominoes after dinner. And then you say, Mom, can 3 spend the night? And she says, no, I'm sorry. We're going to Grandma's early tomorrow morning. It won't work out. So 3 needs to go home now. Okay, 3 is being multiplied with you. So the way to get rid of 3 is to divide. And that's how we get to our answer. X equals 5/3. And you see what I did there? Because of the way my problem was set up, instead of rewriting it, I just put equals X over here so that my answer was clearly arranged, but I don't need to keep rewriting it over and over again. All right, you'll also see these were nice, easy numbers. We ended up with a fraction as our answer, but that's okay. That doesn't bother us at all because we don't have to do anything with that. But it was not scary to solve that. Next example. This time we get fractions in our original numbers. Oy, oy, oy. It's a little messier, but you'll see it's really not any harder. We have the same scenario of the 3 kids hanging out, right? You're the X. 2/3 is your bestie, and 1/2 is the other kid who is invited to play because his mom is friends with your mom, or, you all sit near each other, or these 2 used to be best friends, or, there's a million different scenarios. But 1/2 is the kid who's kind of on the outs. So dinner time comes along, and 1/2 needs to go home. This time we're adding 1/2 because we were subtracting here, right? We do the opposite. Adding and subtracting are opposites, so they undo each other. All right, that cancels out. 1/2 minus 1/2 plus 1/2 equals 0, just like plus 2 minus 2 equals 0. So I just draw a line through that. But I always make sure that I keep my equation in balance. When you do these problems, let me just repeat myself. I've said this a million times this year, but always format your problem exactly like I do. There is a reason, there is a method to my madness. Please do not improvise. Use these exact steps just the way I show them. Okay, now we can bring down our 2/3 x equals, oh, now we have to add these. And they're fractions, which means we have to make the denominators match. Ay, ay, ay. Well, that's okay. It's set up beautifully. Let's see, our LCM will be 6. So we'll multiply this one by 2/2, and this one we'll do by 3/3. Then our denominators will both be 6, right? Okay, I like the looks of that. That seems really good. On top, we'll have 20 and 3. So when I add those together, I'll have 23/6. Oh, that's ugly, isn't it? But that's okay. It can't hurt us. Now, dinner comes. What do you guys do? This time you take Nerf guns and go in the basement and just raise a ruckus. And it's time for 2/3 to go home because you have a dentist appointment first thing. Now, this time, my instincts that say, okay, let's divide by 2/3. Ew, no, 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 no. I don't like that idea at all. That's ugly. And so we've got to get another trick to get 2/3 to go home. And the trick is to multiply by the reciprocal. When you're multiplying by a fraction and you want to undo it, use the reciprocal instead of dividing by. You'll have to do the same on this side, right? This cancels, right? Because if I multiply across, 2 times 3 is 6, 3 times 2 is 6, 6/6 equals 1, and 1 times anything is just that number. So all of this means that we now have x by himself. And now all we have to do is simplify this. I can see that the 3 and the 6 can reduce, right? And that'll be a 1. And it looks like that's all I can do. So our final answer just a second, I'm looking at, I was looking at the wrong problem. X equals 23/4. I glanced at the next problem and the answer there is 23/10. And I thought, how on earth did I get the denominator wrong? But I didn't. I was just looking at the wrong problem. Okay, so this one had fractions. The only drama was we just had to fix the denominators and we had to remember the reciprocal trick here. All right, one more problem in this lesson and we're just going to make it just a weensy bitty bitty bit harder. A weensy bitty bit. That's not very much, you guys. Trust me. All right, I'm going to write it down as it is in the book and tell you what I would do if I was you doing the homework. Okay, there's the 23/10 that confused me last time. Our answer was 23/4. What do I have here? Ew, mixed numbers. So remember that from now on, whenever you see a mixed number, just immediately convert it to an improper. And I wouldn't even copy it this way if I were you. I copied it just so you could see it. But for you, you can just see this in the book and go, oh no, I refuse. So we go 3 times 2 is 6, plus 1 is 7/3x minus 5 times 1 is 5, plus 1 is 6. The denominator always stays the same. 23/10. Now, just as a reminder, there's no need to adjust the denominators right away, just because we can start working. Just wait and see what happens and fix denominators only when necessary. All right, here's the friend that goes home before dinner. We're subtracting him, so that means we have to add him to send him over here. Both sides get it. We want to stay in balance. This all cancels. Now we have 7/3 x equals, okay, now we have to fix 10 and 5. All right, we can just fix this one, right? 2/2, we get 12/10. Now we get 35/10. Ooh, 35/10. We can reduce that, can't we? Well, let's bring the last piece of it over before we reduce, because sometimes it's helpful to leave numbers big and get all the pieces together. So here again, we're multiplying by a fraction. Our best friend is a fraction. How do you feel about that? Our best friend is a fraction. I can live with that. Can you? But remember, to get him to go home, we use the reciprocal. That works better for him. But we have to do it to both sides, right? Now we've got 21 over 21. That all goes away. X is by himself. Now we're ready to reduce over here. And I see 7 goes into 35, 5 times, right? So that's 1 and 5. And then we can do 5 and 10. That's 1 and 2. So our final answer is, I'll just write it down here, x equals 3 over 2. And I think that's a great example of how an ugly problem can have a cute answer, or a cute problem can have a somewhat ugly answer. So don't let the beginning format throw you off. You can do this with whole numbers, with fractions, or with impropies. Just remember I hate to say third wheel, but kind of, right? That third friend, they go home first, and then the BFF stays and goes home later. That's the trick to remembering these. All right, you are now officially smart algebra doers. Yay, goodbye.